Hello everyone. In this video, I will solve a problem from the topic integral, which is in the form of px plus q root over ax square plus bx plus c. To solve this problem, you should know these formulas and you should know how to use the substitution method. Generally, integral of this type require this formula, but this question does not need this formula. So let's see how to solve this problem without using this formula. So the problem I will solve in this video is integration of x plus 1 into root over 2x square plus 3. So first step is to multiply this root over 2x square plus 3 inside this bracket. So we'll multiply this term with x and with the second term 1. So what I will get? I will get integration of x into root over 2x square plus 3 plus 1 into root over 2x square plus 3. So in the first step, I have multiplied this inside this bracket with the both term. So I got this. Now we यहाँ पे क्या plus है, तो we will apply this integration on this both term. So I will get integration of x into root over 2x square plus 3 into dx plus integration of root over 2x square plus 3. Okay, now we will denote this first integration as I1 and the second integration as I2. So equals to I1 plus I2. Now we will solve this integration separately. First we will solve I1. So I1 is basically integration of x into root over 2x square plus 3. To solve this integration we will use substitution method. Now to use substitution method we will assume t equals to 2x square plus 3. Because already x is present in the function, so I will assume 2x square plus 3 as t. So let's say t equals to 2x square plus 3. Differentiation of this function will be 4x. Because here 2 is there. Now derivative of x square will be 2x plus derivative of 3 will be 0, which is constant, therefore derivative of 3 is 0. Now plus 0 will not matter anything. 2 into 2x will be 4x. So dt by dx will be equal to 4x. Matlab derivative of t with respect to x is 4x. Now we have to substitute. Multiply dx. So dt will be equal to 4x into dx. From here I can find x dx. So x dx will be 1 by 4 dt. So now we will substitute 1 by 4 dt in place of x dx. So this will become basically integration of, and we have to substitute t in place of 2x square plus 3. So it will become root over t into dt upon 4. From here I can take the constant 1 by 4 outside the integration. So this will become 1 by 4 integration of root t dt. Now root t, integration of root t. To solve integration of root t, we will apply the formula integration of x power n. So integration of x power n is basically x power n plus 1 divided by n plus 1. So we can rewrite this root t as t power 1 by 2 and we'll apply the formula. So 1 by 4 t power 1 by 2 plus 1 divided by 1 by 2 plus 1 plus c1. c1 is the constant for the integration I1. Now 1 by 2 plus 1 will be 3 by 2. So t power 3 by 2 divided by 3 by 2 plus c1. Now this will cancel out. So 2 and 4 will cancel out and the remaining will be 2 into t power 3 by 2 divided by 3. Now 3 into 2 will be 6. So 1 by 6 t power 3 by 2 plus c1. And what is t? T was basically 2x power 2 plus 3. So I have assumed 2x square plus 3 as t. So I have to substitute the value of t in the solution. Now this is the solution for the integration I1. Now we have to find separately I2. So I2 was basically integration of 2x square plus 3. So root over 2x square plus 3. So this was I2. To solve I2, we will use the formula root over x square plus a square. Before that, we have to use a substitution method, because we can rewrite this as root 2x whole square plus root 3 square. So we will write this afterwards. Let's say 3. So I can rewrite this as root 2x whole square, because root 2x whole square will be 2x square. Now we will use substitution method and we will assume t equals to root 2x. We will differentiate this with respect to x and I will get root 2. From here we can find dt equals to root 2 into dx. From here we can find dx equals to dt upon root 2. Now we will substitute t in place of root 2x and we will substitute dx in place of, we will substitute dt by root 2 in place of dx. So this will become integration of t square plus 3 into dt by root 2. Now after substituting, I can take the constant outside. 1 by root 2 is the constant that I can take outside the integration. So I will rewrite this as 1 by root 2 integration of root over t square plus 3 into dt. Now in place of 3 I can write root 3 square. I can write it as root 3 square and dt, this is dt. So I will apply the formula here. Which formula? Formula is root over x square plus a square. And what is the formula? So integration of root over x square plus a square. So formula for this integration is x by 2 root over x square plus a square plus a square by 2 log x plus root over x square plus a square. So this is the formula for this integration and we have to apply this formula in the question, in the integration. So 1 by root 2 into, so x by 2, that means it will be t by 2, because our function is function of t, root over t square plus a square, that means 3, plus a square by 2 means 3 by 2 log x means t plus root over t square plus 3 and plus c2. c2 is the constant for the integration I2. Now we have to substitute t. T was basically root 2x. Now after substituting I will get 1 by root 2 and this will be multiplied whole, 1 by root 2 whole multiplied to this term. So now t is basically root 2x divided by 2. Here root 2x whole square. So root 2x whole square will be 2x square. So I will write directly as 2x square plus 3. 3 by 2 log t was basically root 2x plus root over root 2x whole square. So root 2x whole square will be 2x square plus 3 and plus c2. c2 is the constant for the integration. Now what I can do here is I can multiply this root 2, means 1 by root 2 inside this bracket. So it will get multiplied with this first term and as well as in the second term. So on multiplying I will get root 2x divided by 2 root 2. So this root 2 and root 2 will get cancelled out. So remaining will be x by 2. So I can write directly as x by 2 into root over 2x square plus 3 plus 3 by 2 root 2 log root 2x plus root over 2x square plus 3 plus c2. So this is the solution for the I2 integration. Now we'll substitute the value of I2 and I1 in the equation of I. So equation of I is basically, so let's say this original integration as I. So let's say this is I. So this is equation of I. So I is basically I1 plus I2. So I is basically I1 plus I2. What was I1? So I1 was basically 1 by 6 into 2x square plus 3 power 3 by 2. This was I1. So 1 by 6 into 2x square plus 3 power 3 by 2. This was solution of I1. And solution of I2 was basically plus x by 2 into root over 2x square plus 3 plus 3 by 2 root 2 log root 2x plus, so root 2x plus root over 2x square plus 3 modulus plus c. So here plus c. So constant for the integration I1 was plus 1 and constant for the integration I2 was +2. So upon adding C1 and C2, I will get another constant. Let's say that constant is C. Now this is the final solution for the given integration. If you want to learn more about different forms of integral, you can check the video on the screen. Subscribe and stay tuned for more videos. Thank you for watching this video.